Good morning, I'm Vidyananda here to present my research on the topic effect on humans due to heavy metal contamination in Weras, Ganga. To introduce my research, heavy metals are extremely toxic and can enter the human body via respiration, ingestion and skin. Weras, Ganga is a water body surrounded by many sources of contamination and therefore poses a great risk to human health. When considering the methodology, two subbasins around the Karadhiana dump site were selected and sample locations were selected considering areas with higher contamination sources and locations where locals go fishing regularly. Water samples of 300 milliliters was collected to PE bottles. It was important to muddle the water and collect samples at least 50 centimeters below the surface to obtain a maximum concentration. Then the samples were transferred to the laboratory in an ice box to maintain the original composition, and samples were tested for lead, cadmium, chromium, copper, zinc, and mercury. Thereafter, results obtained were analyzed with safety standards and remediation techniques were suggested. Finally, a mathematical model was developed to predict heavy metal concentrations. When considering the results from samples tested, zinc was found in highest concentrations deposited in water, followed by lead, copper, chromium, cadmium, and mercury. Highest concentrations were found in a small lake formed by water flowing from the Madala and Weras Ganga, where locals engage in fishing activities regularly. Also considering past data from 2007, zinc concentration had increased drastically while there was no significant change in concentrations of other metals. Also, it's important to note that the samples were collected during the rainy season and after the COVID-19 pandemic, where the contamination rate had decreased drastically. Considering safety limits and standards, lead concentration found in samples had exceeded the safety standards specified, while other metals were marginal to the standards except for zinc. Considering other safety standards specified for bathing, recreational activities, and irrigational activities, standards are not specified for most metals, but however, the WHO has emphasized on the fact that the presence of heavy metals in water itself is risky for human health as they easily accumulate in the human body. When comparing results obtained with safety limits of potable water, there is a high range in difference which signifies how contaminated water flowing in Weras Ganga is, although the water is not used for drinking purposes. Therefore, through the analysis, it has been evident that heavy metal contamination in Weras Ganga is a huge problem that needs to be addressed due to the risk it possesses to human health. When considering treatment for heavy metal contamination in Weras Ganga, filtration methods using membranes and walls can be used along the banks of the river, while adsorption materials such as clay minerals can be used in buffer zones to prevent contamination of the river. However, considering the vast area, treatment using plants is the most effective as entry of contaminants to the river can be prevented by using plants with phytoremediation abilities. Further in the research, mathematical formulas were developed for three metals. Lead, which was the metal that exceeded safety standards specified for aquatic life, for zinc as it was the metal with highest concentration, and also for mercury as it is the most toxic heavy metal. In developing the model, concentration of metals was used as the dependent variable and flow rate was used as the independent variable. Second-order polynomials were developed with the least error and the models were validated using available data and level of accuracy. In conclusion of my research, by analyzing test results with safety standards and past data, it was deemed that heavy metal contamination of water in Weras Ganga poses a risk to human health due to its ability to enter the human body easily. As this is an aggravating issue which is not addressed or made aware for the public of its severe risks, it's important to remediate this problem for health issues. Therefore, in the future, the research can be further developed by determining proper and accurate method of treatment for heavy metals, and the mathematical model can be improved to obtain more accurate results. And that is the end of my research presentation. Thank you.